Hello, everyone. Welcome to this episode of Cloud Currents. I'm Dave McKenney, and today I'm joined by Tim Chou. And we're going to be talking about a few things today, most of which will be involving cloud computing and AI, topics pretty near and dear to Tim. So, Tim, how are you doing today?
I'm good.
That's great. So you have quite the career. Work with Oracle, multiple board member and chairman seats, lecturer at Stanford. Could you maybe unpack your career a little bit for us before we get into some detail?
Yeah. Well, it's that you're in Nebraska. I went to graduate school at the University of Illinois and lived through lots of Midwest winters. Came out to California to work for one of the original Silicon Valley startups called Tandem Computers. Some of your listeners may know. I went from there, ended up doing, I call it 2 tours of duty at Oracle, with the last one being the president of the cloud computing business. In parallel, I taught at Stanford University. I still do. I started teaching in 1982, computer architecture, actually at a time when you couldn't get a bachelor's degree in computer science at Stanford, which is a weird thing to think about. When I retired from Oracle, I was hanging around the department. They said, "Oh, come back and teach." I was like, "God, that's a lot of work." So they said, "How about a seminar class?" I went, "Well, I've been a manager for a lot of years. Why don't I, do that?" And so we started this class on cloud computing. Any of your listeners, CS309A.stanford.edu, and you'll get a little glimpse into it. I do the first and last lectures, which you can guess are, pretty much the same. And in between, I have guest lecturers who are all CEOs of public companies, starting out with, people that I knew, like the CEOs of Salesforce and WebEx. But over the years, realizing that no one was offended to be asked, I broadened out. I mean, last year we had the CEOs of HubSpot, Informatica, Franklin Templeton, and we ended with the CEO of Intel. That, coupled, as you just said, I've been sitting on public company boards for 20 years, became the chairman of the Alchemist accelerator, and about 3 years ago, basically decided to come out of retirement to work on the Pediatric Moonshot, which I can talk about later. But in essence, it's a spin out of the class. We have engineered a next generation, privacy preserving, real time, in the building edge cloud service in pursuit of the objectives of the Moonshot mission.
Yeah, that's amazing. Yeah, I'm looking forward to talk more about that for sure. I'm curious. So you've got such a history in technology. If you weren't, we like to play this game at my household. Like, Dad, if you weren't in technology, what would you do? So if you weren't in technology, what would you do?
Well, first of all, it's really hard to think about, because I think I wanted to be playing with computers from the age of 12. So I don't know that I ever had anything else. But the one thing which I know everybody will find odd is I always wanted to design perfume bottles.
Well, that's awesome. I find that in our field, like, you get the most expected, responses, from being a chef to mowing lawns to whatever. Now your journey in technology will definitely tell you how far you're willing to go to get away from it,
Yeah.
So many decades in technology. You've seen a lot of milestones in the industry that probably have affected and informed your career, but what were some of those unexpected turns over these decades? I obviously, you just mentioned the lecturer position at Stanford was a little unexpected, but it seems to have turned out for all the better for probably your students, certainly. But what other expected turns along the way?
Well, I'll tell a story, which is a good example of,
Oh, we love stories.
Serendipity or what, expectation. So
yeah,
I'll take the listener back to, it's 1999. If you remember, I mean, we are in the heart of the first internet boom, web van, e-toys, everything. I am talking to a company who is about to raise $50 million if they name the CEO, and they're going to focus on a website for Korean teenagers. And I'm sitting there going, okay, that's kind of interesting. In parallel, I had already been at Oracle before. Some of the folks at Oracle said, well, we'd like you to come back and talk to Larry about running this new business. In fact, if you go back in history, we called it Business Online for a while. So why don't you come talk to Larry about that? So on the very same day, I literally had a conversation in a garage in Palo Alto with the founder of a company building websites for Korean teenagers. And that afternoon went up in the giant Oracle towers and met with Larry about running this brand new business.
What is it about garages and good ideas?
Yeah, well, just to tell the rest of the story, for a variety of reasons, it was nice to be able to say no to Larry 3 times, by the way. But after the 3rd time, I'm going, well, this is kind of stupid. What do I know about, Korean teenagers and the media business? And so I made a fateful decision to say yes to Oracle, going back to Oracle. And if everybody remembers the story, within about a year, that's when the whole world crashed. And in essence, I was in there at the beginning of what we now refer to as cloud computing, meaning, letting the builder of the software, in essence, deliver it as a service, ultimately hardware as well. So, but yeah, that was an unexpected twist.
Yeah, no, that's a good story. I think it's funny. It's just the number of ideas that have come out of people's garages and turned into billion-dollar industries. So you started out a little bit there about what you're doing at Stanford at CS309, which looks very intriguing with your guest speakers. How do you get the list? I love what you said about it. You don't be shy to ask. I can't remember what you said exactly, but at some point after you started to get a few of your acquaintances to come speak, did the doors just flood open? Has anybody ever said no to you, like as in they don't want to?
Just give you a sense of scale of this. We probably had at this point 150 unique speakers, public company CEOs, which means I probably talked to 450 to 600 different ones, because I'll get to how we end up with we do 8 a year or 8 a quarter. And so out of that, I would tell you, I've only seen 2 cases where they said, no, I just as soon not.
They probably have legitimate reasons. The list is, honestly, if I had to, somebody put it in front of me, be like, there's no way somebody gets these types of speakers, but it's pretty incredible that the people that you've gotten in your door to speak to students.
Yeah.
It's amazing.
Yeah. No, I think it's obviously it's an interesting opportunity for them, because I say, look, this is not a shareholder, an employee, or a customer, which is who you're always talking to. This is an opportunity to talk to a different group of people. And so while we do have a technology conversation, there's also, I say, hey, you've got 150 bright young minds. If you'd like to do some career advice, go for it. So I think there's recruiting. That. Yeah, well, and recruiting. But I have to say, I do that class as much for me as for the kids.
I can believe it.
90% of these people, I meet them on the day that we do the lecture. So I don't know what they're going to say. I mean, I give them an outline of what to talk about, but yeah, so it's always interesting stories, ideas coming out of that.
Yeah, that's awesome. Well, I could definitely go into some more about the course. I'm really intrigued. Let's talk about Pediatric Moonshot and give a kind of a synopsis. You talked about it a little bit earlier. Real-time health information, no matter where you are. I can already tell where the inspiration is probably coming from, but let's hear it from you and talk about where this project originated.
Yeah, well, the class is the origination. So a student shows up now, I don't know, 7 years ago, and he sends me an email and says, I'm a little old school. I'd like to meet the professor. I went, okay. So we arranged to have breakfast at Joni's Cafe on California Avenue for those locals around. I'm sitting there. He comes walking in. I'm looking. I'm going, doesn't look like a regular student. Turns out he has an MD, an MPH, an MBA. He's chief of pediatric cardiology at the Children's Hospital in Orange County. And so I'm looking at him going, why are you talking to me? There's nothing I know that could help you, right? And he goes, well, actually, I've been watching Jeopardy, and I think that it's time for big data, cloud computing, and AI to meet medicine. And so he is actually enrolled in the bioinformatics program at Stanford, and that's why he is in my class. And for those your listeners, check out Dr. Anthony Chang. He's a major voice in this transition in AI in medicine. The other thing that happened was Anthony's a major league networker, and so he kind of introduced me to their tribe. Just to give you a sense of this, there's only about 500 children's hospitals in the world. He runs a meeting called PEDS 2040. The very first time I went there, he asked me to do a keynote. I'm pretty sure there were 100 of those hospitals in the room. And it wasn't like a hospital administrator. It was this strange character who's a pediatric endocrinologist who wants to talk about graph databases, right?
Wow. So multidisciplinary people.
Yeah, I remind people, the kids that decide to go to medical school or pre-med in high school, they were pretty much the smart kids, right? That was kind of the thing the smart kids did. Well, smart kids turned to be smart adults too. So it's not too surprising that some group of them is, interested in graph databases. So anyway, so I got introduced to their world, and I learned things like, they're still using CD-ROMs to pass data around. In fact, there's a really sad story. It's a friend of a friend of mine. The kid went in for optional shoulder surgery at a regional hospital. There were complications. They decided to airlift him into the Children's Hospital in California, and he arrived, but the CT scan did not, and he died later that day. Now, all of us obviously don't know whether having the CT scan would have made a difference, but it sure wouldn't have hurt, right? And so today, all the time, people are still using primitive technology to share data, right, or share images. And then at the other end, and, this is where you have to think, in pediatrics, 60% of the rural counties in the United States have no pediatric expertise. I'm not talking about cardiology, orthopedics, like subspecialty, like none, zero. 3 states have no pediatric emergency physicians, like zero. If you go global, you go, there's actually only 300 pediatric cardiologists in India, and we all know how big that population is. There's one guy in Rwanda. So if there was ever a place in which AI could make a difference, you're looking at it, because we can't grow enough pediatric cardiologists or whatever, build enough medical schools, right? So the second observation was, we could use this technology to build AI applications, but AI applications require access to a large amount of diverse data. Otherwise, you can't train them accurately. So that all came together when COVID kind of began, and I'm sitting around thinking to myself, we're going to sit around watching Netflix all day? So I thought, maybe we could do something better with our time. So I decided to come out of retirement, launch the Pediatric Moonshot. So what is our mission? Our mission is to reduce healthcare inequity, lower cost, and improve patient outcomes for children locally rurally and globally. Now, how are we going to do that? We're going to do that by creating privacy-preserving, real-time applications based on access to data in all 1 million healthcare machines in all 500 children's hospitals in the world.
Wow.
And by healthcare machine, I mean everything from CT, X-ray, ultrasound to, gene sequencer, blood analyzer, ventilator, et cetera. So that's the mission. As I kind of alluded to, and, this is cloud currents. We looked at and we said, like the original Moonshot, we went, we need to build a new rocket to do this. And so we engineered a real-time privacy-preserving in the building. When I'm talking to the clinicians, I go, it's in the building edge cloud service, so that servers are in the building in Children's Hospital of Orange County. Why do they need to be in the building? Well, the only way you can talk to the ultrasound or the, gene sequencer or the blood analyzer is you have to be on the network in the building with, that healthcare machine. So you could guess we've had to engineer we engineered 30 security and privacy features. One of the core team is a former student, has 15 years of privacy law experience. So we knew that was job one. About a year and a half ago, we said, hey, it's time to leave the lab and let's go into the world. So we deployed what we refer to as edge zones in 8 children's hospitals on 3 continents. And so we're way out of just hypothesis about doing this. Our focus recently is on what we call the Mercury program and the Gemini program, in keeping with the Moonshot. So Mercury is to build a global image sharing network to allow non-children's hospitals, for example, rural hospitals, to share images with experts at children's hospitals. So primary first use case is emergency medicine. So just give you a simple example of this. There is a hospital in Willits, California, population 5,000, north of San Francisco by about 4 hours. To this very day, when they have an emergency, they ship a CD-ROM to UCSF or to Stanford or to UC Davis or to Shriners Burn Unit. And the future we're creating is, no, you don't need to do that. The application looks remarkably like Instagram. You'll be able to select the image off the X-ray machine, no training required, and share with an expert, in the speed of light, not 4.5 hours later, an image. So Mercury is all about sharing with a human expert, and Gemini is our program to build AI experts, It's an AI research lab for children's medicine. The big innovation there is we have to figure out how to do decentralized learning. So ChatGPT, which obviously is the most visible example of this, all basically assumes a centralized architecture. I'm going to take all the data, I'm going to move it to AWS or Azure or whatever. I'm going to, learn on it, and then I'm going to deploy the application there, as we all have seen. Well, that whole idea doesn't work in medicine. I mean, number one, the data sizes are enormous, so that you're gonna soak up a lot of network bandwidth if you're moving MRI or ultrasound images. Number two, what about privacy? I mean, aggregation of large quantities of data is not privacy management. And in fact, when you look globally, countries like Norway are saying Norwegian data is not leaving Norway, And then the last point is, are you going to do real-time applications from a server that's 1,000 miles away? No, you want to have that deployed at the point of care, which frankly could be on an ultrasound machine in an ambulance that's headed to an emergency room, So the trick technology problem, which I think your technology listeners will be interested in is, so how do you learn in a decentralized way? And so there's been a lot of work on consumer side in so-called federated learning. So Siri actually works this way, which is, can I learn? I don't take David or Tim's voice print and send it to the Apple cloud. Why? Privacy, network bandwidth, right? So can I learn on what you said locally and only transmit model weights, which are just a bunch of floating point numbers, to an aggregation server? And so Google Keyboard actually works this way. And so we have done early experiments that indicate the same thing could occur in medical imaging. And so the lab is to bring this up and perfect the techniques for doing decentralized or federated learning in cardiology, orthopedics, emergency medicine, neuroradiology, et cetera.
Yeah, so that's fascinating. So it's you were just prior to that, you were talking about the need for like almost like regulatory reasons, as well as just overall the size of the data it really inhibits bringing it all to a centralized place, that you're going after this edge solution.
Yep.
But now you've also brought in that sort of personal touch to it too, that because this has privacy rights beyond regulatory, that this is something that's personal to that whoever the owner is, keeping it right there with them, but still taking the benefits of what these models, weights, and parameters from AI bring.
Yes.
Yeah.
Yes.
So you mentioned though, so initially, because I see that there's multiple things that you're solving or having to solve for here. The connectivity need to get past USB sticks and CDs, and by the way, that story is awful, but I have personally had to do that. I know that at one point for an MRI, I had to go to the bottom floor of where I was at. I actually had to wait in the lobby 30 minutes to get a CD burned at the time, and then drive to a different clinic, I don't recall where, and had to do all that. But it was multiple hours. Thankfully, it wasn't a life or death thing for me. So I can only imagine situations where that's just got to be so defeating for people. But connectivity, that's obviously huge. But then the connectivity and the real-time nature begets your next problem, where it's great. I can get connectivity and outreach through or to like a centralized set of high demand professionals, but now you're met with the problem that there's not enough of these people. If you put these people, you book them every 15 minutes on a screen share to go around the clock, there's just not enough of them. So now you talk about bringing artificial intelligence to learn from these people, and all this is getting to one of my questions here around the AI side is, humans around the world, and I'm going to say this relatively speaking, humans around the world are still humans. We all kind of have the same makeup, right? I swear hopefully that sounds smarter than it did in my head there. But when it comes to the systems in first world all the way to third world countries, they're very different. In America especially, we are very fortunate to have some very bleeding edge medical systems. So I'm kind of intrigued by the data set that you're bringing into AI, and what AI might be picking up and what it might have thought it knew simply by looking at a data set, say in the Americas, but then when coupled with data that it's coming from maybe third world systems that we're talking about, like MRI or imaging machines that are probably 30 plus years old and otherwise would have made incorrect assumptions. Hopefully you understand where I'm going here, but I mean, that's got to be a technical challenge here, maybe even a cultural one too, with these systems being so different around the world.
Yeah, well, let me say how we're trying to address that. So that's why when we said the mission is 1 million healthcare machines in all 500 children's hospitals, we're not trying to solve the problem right now about, well, what does a machine look like in a clinic in Kenya? We are, so just to use that one as an example, Gertrude's Children's, which is one of only, I think, 5 children's hospitals on the entire continent of Africa, just to give a sense of this. Yeah, we're working with them. So the type of equipment that we would see at a Gertrude's or Bambino Gesù, which is one of the largest children's hospitals in Europe, is not too dissimilar to what we're seeing here, right? So we have, let's call it, at the same generational level of machines, at the same generational level of networking infrastructure, et cetera. So that's step one, is let's get the primary things connected, right? And be able to leverage the data. I'll just give you a simple example of this. There's a condition called focal cortical dysplasia. If left untreated, the child has epileptic seizures. There's a kid in Florida right now. He's, I think, 13 years old. For the past 12 years, he has had seizures 2 to 3 times a day. At night, he wakes up screaming. They MRI imaged him very early on, didn't see anything. He has been on a multitude of drugs. I mean, some that they could afford, some they couldn't. They were getting ready to put in electrical implants. They MRI imaged him again. They now believe he has this condition, which is a brain lesion. And if you discover it, and I've actually seen the MRI images, I mean, frankly, David, if you and I saw it, we go, I don't know how that fuzzy thing is different than this fuzzy thing.
Probably looks like a white spot to us, right?
Yeah, it's just like, but okay, if it is, you can surgically remove it, and the kid's cured for life. I mean, isn't that incredible?
Yeah. It is absolutely incredible.
So the good news is, in the United States, this condition only happens 2,500 times a year. Okay, that's good news. Of course, the bad news is no one pediatric neuroradiologist sees enough cases. So the idea that even the expert can miss is like obvious because you can't see this that often. Now, on the other hand, what if we had all the data from all the MRI machines in all 500 children's hospitals? We could build a friggin' ultra accurate focal cortical dysplasia diagnostic that now every kid, whether it's an MRI machine in Kenya or here or in rural California, the machine could go, hey, red, green, yellow. Red, you really ought to go take this kid in. Yellow, somebody ought to look at this again, right? And
so is this stuff that would otherwise typically, number of medical dramas that you might watch on TV, but like, is this stuff that would otherwise surface like in medical journals that somebody might know, oh, I read about this, maybe one physician who had a case like this and let me talk to them. I mean, is that really how it plays out today prior to?
Absolutely. That's how it plays out. It's an accidental walk through the system that if you're a parent and you're persistent, maybe you gradually worm your way through to someone who goes, yeah, I know what that is. Increasingly in their community, they use the word rare diseases. And when you and I hear it, we go rare. We focus on the rare. Oh, it's rare. But I'll tell you, my observation of this is everything is a rare disease. There's tons of this stuff out there that could be genetically diagnosed, could be image diagnosed, and, talk about lowering cost. We could severely lower cost if you start diagnosing this stuff early. Early detection and early diagnostic is a way better answer to how do you lower cost and, by the way, improve patient outcomes. I mean, in orthopedics, there are plenty of situations that they will tell you if they could have detected this early, they would have saved, spending $100,000 on a surgery, and the kid would walk better. It's like, we have the technology. I mean, it's so clear at this point. The technology exists to pull this off. That's why while we call it a moonshot at some level, at another level, it's just execution. We can do this.
Yeah, and who do you think in your mind stands to benefit the most? Is it, obviously there's the global connectivity of bringing these types of services to, as you've pointed out, places that don't have anywhere near this ability. There's also the 1%ers, maybe that's what we'll call it, these very rare or not really well-known diseases, or what you want to call it, there's no doubt an economical benefit. Right? There's a lot of probably money here, but let's stick with those first two. Where do you see the biggest change that this would provide? Is it to bringing answers to those very rare diseases that don't get as much exposure, or is it just bringing the overall service?
Yeah, I mean, what we're building, if it's not clear, I should say it again. We are fundamentally building a platform that could build applications from the very rare to the very mundane, just to be clear about it. I think at the end of the day, where's the impact of what we're doing? And we can just stay in the United States for right now. If your mom works for Google and you live in Palo Alto, life's okay. I mean, what we're doing is going to make some benefit, but the impact is really the kid that lives in rural Nebraska, whose mom does not work for Google, right? And, that's where the gap is right now. This healthcare inequity problem. I mean, when you realize that, I mean, it's even here. I was just talking to a pediatric cardiologist over at Stanford. You drive 1 hour south to Salinas, there isn't a pediatric cardiologist to be seen. I mean, I'm just talking about the Bay Area right now.
I guess it's when you've grown up near the facilities, you don't recognize that what you have, so many don't.
Well, and also you're connected. Your mom works at Google. Well, her sister's friend is a pediatric cardiologist. I mean, that's the world we all live in, right? We're connected together. We're a social means, right?
Yeah, it strikes me that this Moonshot almost like presents as like the ultimate second opinion, right? Like people always recommend get a second opinion, third, fourth, whatever. It's almost like this is like the going to be your first and last second opinion.
Well, in some cases, it'll end up being the first opinion.
Right.
Right.
Well, that's incredible.
Yeah.
Well, taking the AI, let's kind of keep fast forwarding here, and let's stay on the AI topic. So there's obviously a lot of ethics and regulations and things that you've started to mention in healthcare, but just in general, what concerns you today with how AI progression has been handled, whether it's around ethics or just, I'll make an analogy here. We all saw how social media and what it's done and how fast that launched onto the scene, and some of the repercussions that we're still paying for because of very late regulations towards it, or even just awareness to what was some of the abuses and things that were happening. But do you think we're going to repeat that with artificial intelligence? Do you think we'll do better than some of these mistakes? Or are we buckle up, it only gets worse from here?
Well, if you can't guess, I'm an optimist by nature, so.
That's good. We need more of that, right?
I hope that we're better at it. One of the things, just to come back to the class, I mean, I reach out to the law department all the time. Well, a couple of years ago, we had 8 law school students in the class, right? Because I think, number one, you can't have a conversation about policy and law and all these sorts of regulation in the absence of knowledge. And unfortunately, I think that's where we are today. I mean, you don't need to go to too many Senate hearings and go, what does anybody on the other side know about any of this stuff?
At this point right here, you're spot on, because it leads to the people who create it making the policy, which is very much a conflict unless somebody really is doing right by the world. I mean, it's a very interesting predicament.
Well, and I think, at least in my history of tech, I mean, tech used to be very much a backroom thing, right? Let's make payroll run or, do our accounting and whatnot. I mean, obviously at this point, it's way out on the other side of this. So if the collective we don't understand this, right, appreciate it, et cetera, then we will continue to, quote, make mistakes. So I hope, right, and I mean, I do try to do my part of let's get people smarter about what we're trying to do here, what works and what doesn't work. I mean, lately, just a simple example of this is I've been telling people, stop using the word AI. Because all that happens is, I say most conversations, you could actually replace the word software with that say AI, and it'd be the same thing. Because, it's magical that it works. Well, that's just software. Okay, fine, right? Instead, the real technology break that's happened is these large language models, of which I tell people looks a lot like microprocessors to me, meaning there's not going to be a whole lot of people building them because they're not easy or cheap to build. So we're not going to have 3,000 of them. We're probably not going to have 3 of them either. So then the question, which, David, I'm not sure how old you are, but back in the day, we did have, 10, 20 different microprocessor architectures. And the question then becomes, well, what are you going to do with it, right? What are you going to build with this? And I think that's the question in front of us right now is, yeah, LLMs are really cool. ChatGPT, put it on my browser, all that. Yeah, it's very cool. But how do we apply them to, and obviously I'm working in this, how do we apply it in medicine? How do we apply it in, banking? How do we apply this technology becomes the question. And I think the hard part of this, which we all are going to have to figure out, is we have worked for, let's call it 40 years with deterministic software, debit and credit. If you're going to debit $1, you credit $1, not 99 cents, $1, right? We know how to do that kind of computing, right? Which is deterministic. The world we are entering is not. It's probabilistic, right? And how do you know that release 2 of your, LLM application is more or less accurate than release 1?
Yeah, especially when they're being trained on previous data from previous models.
Well, and that you may choose to further train on, all of these things I'm sure there's researchers out there who have the thoughts on it, but the broader we don't know how to deal with this, right? And I think it's in that pursuit of understanding how we're going to do this, educating ourselves, educating the consumer of these technologies, right? That's where this is, I say, hyper important, because we're trained that if it's printed, it's truth. Of course, we're progressively being trained that if it's printed, it could be anything.
Yeah, no kidding. So do you see future state here? This is all very early in its days as far as the broad adoption for things. I mean, ChatGPT has done wonders as far as adoption goes. But you're right. Most won't have the infrastructure to train a language model to that extent. But do you see industry-wise that we'll see LLMs that are very specific to industries like banking and healthcare for a lot of reasons? I mean, there's probably intellectual property, there's probably privacy regulatory reasons, but versus this idea that I'm going to build one ubiquitous LLM that I can feed it a healthcare question, I can feed it a finance question, right? I guess said a different way, there will be a need for general LLMs like ChatGPT, but do you see that there will be a need for very specific, supervised, purpose-built LLMs in industries, or do you see it going a different direction?
So I think as we today see enterprise applications of all ilks, we will see LLM applications of all ilks. And let me just give you an example that we're working on right now, which is, what if you took an LLM, trained it on all of the accepted research papers, et cetera, in cardiology, right? And then what if you took David's EMR records from the past 2 years and trained it on that? Now I would actually have, we'll call it Chat David, right?
Personalized, yeah.
Yeah, whether, by the way, that's a clinician who, I've been through this recently where you just laugh. I mean, you have the the intern or the fellow asking you questions about your condition, staring at your electronic medical record. But once you see one of these electronic medical records, you realize why they're doing that, because there's no way. There's just tons of text and documents and whatnot sitting in there. They can't even read it, right? So that even your history is lost, other than the context created by some doctor you've seen for 3 years. That's it. It's the context in their head. What's in I'll say the context, the history's in their head. That doesn't need to be anymore, right? We could build Chat David where you could say, well, when was the last time that David had a CT scan? What's the relationship between his blood level and blah, blah, blah? Could you write me a 40-page summary of his medical condition? Could you write me a 2-word summary? I mean, there's so many ways you can think about this, but that's only going to happen if you can progressively train these things on progressively more, I'll call it fine-grained data, curated, right, et cetera.
But you're talking about something that a lot of people would love, right? It's almost like your own personalized AI assistant. It's like Iron Man's Jarvis. Like you've got somebody that you can. I mean, there's any number of analogies in the movie world, but
right,
yeah, and I think that I think most people would gravitate to a solution like that. The amount of things that it could do for you versus what you'd be giving up. It's amazing. But I can see a lot of people also being very concerned with the ethics of it, right?
Well, you have to be conscious of how you're going to manage security and privacy. Back to why the infrastructure we're building has all been designed around security and privacy management. You have to have the infrastructure to do this sort of thing. Yeah.
Yeah. It's really neat. Gosh, we've already blown through an hour. I had a list of probably 3 times as many questions as we got through. We didn't even talk about really cloud computing and your outlook on we talked about some future state things, but I appreciate it, Tim. This has been amazing. And I look forward to seeing, and I'm going to track the progress on the pediatric moonshot and let's see if I can find a way to snag a seat in your class. Hopefully that Stanford class is allowed for remote Stanford attendees. Somehow I can find a seat there.
Yeah, well, the university knows how to monetize. So yes, it is possible.
Perfect. And right, they should. It's all back to economics, right?
Oh, yeah.
Economics back it all up.
David, can I do a final commercial message?
Absolutely. By all means.
So yeah, the Pediatric Moonshot, just to let everybody know, I've been funding our efforts over the past 3 years. The next step in what we're trying to do, we have estimated at $112 million. So I said, yeah, it's a little bit rich for me. We are not going to our venture capital friends who are not interested in pediatric healthcare. And we're not going to the children's hospitals because they don't have a whole lot of money. And in principle, we are building a network. And so one node in the network is not advantaged. So we are going down the twin paths of government sponsorship. Some of your listeners may be aware of some new agency created called ARPA-H, but we're also trying to talk to USDA, government of Singapore, government of the EU, because we fundamentally are building infrastructure, and that seems like something a government should fund. The other angle is corporate sponsorship. So I'll give you the simple shorthand. I was giving my friends at Juniper Networks a little grief, and I said, hey, you guys spent $1 million to put a logo on a Formula One race car, right? And they go, well, actually it was more than $1 million. I said, okay, you're just making my case for me, right? Why shouldn't corporations become sponsors of the Moonshot? So for any of your listeners who are interested in learning more, reach out, www.pediatricmoonshot.com. You can register for a newsletter. We've got podcasts that you can put in show notes to show people about and for people to follow along or become part of what we call the Moonshot crew. So appreciate you giving me that forum on Cloud Currents.
And I went to the site. I was unaware of the project that you guys had been working on until now, and there's a lot of really great info on there, and it's a lot of stuff that really people I think can relate to. So Well, that's fantastic. Tim, thank you so much. This has been a great talk.
Thanks for having me, David.